Hi, I'm Anne Watson, and I'm going to talk about joined up conceptualization, by which I mean what is the conceptual journey that is made available to learners in a lesson. So how might they build up the concept being taught in a lesson? And my way of doing this is going to be to talk about 3 lessons that were co-planned by a team of teachers and think about ways in which they differed. So my way of understanding lessons is to ask what's available mathematically in the public activity of the classroom. I don't have a list, a tick list of all the things that make a lesson good or bad or anything like that. I'm interested in what is the mathematics that's made available for learners in the classroom, in the lesson. So, for example, what's the class supposed to be doing mathematically? What are they supposed to be thinking about? Is it clear from what the teacher is doing what they're supposed to be thinking about? And what is being said and done and by whom that is shaping and is shaped in the activity that's going on? Where is learners' attention? Where is it being directed to? And where is it? And all those things contribute to what the learner experiences as the object of learning in a lesson. So I'm going to look at some lessons taught by Year 7 teachers, planned by a team of teachers. All the classes were all-attainment teams in an inner city comprehensive school many years ago now. I don't have videos of them because videos weren't permitted by the school, but I'm going to give you brief descriptions of 3 of the lessons. And the teachers had a shared purpose, which was to understand how and to learn how to construct some simple loci. That was their purpose for the learning. And the lessons were 70 minutes long. And the team agreed that there would be 2 main tasks, but the teachers could decide in which order they did these. One of the tasks was to make physical loci by following instructions in an open space. For example, find a place to stand so you're the same distance from these 2 points. And the other task was to do compass and straight edge constructions of the same loci. And all the teachers agreed to include construction of a circle, angle bisection, and perpendicular bisection of a line segment. So what would you do and why? You can pause this video and think about it. I'll go back to the previous slide. So the teachers chose the order of the tasks, whether to use rulers with measurements on them or only straight edges of some sort, what language to use, how the connections were going to be made, and whether all of the students would do the physical task or some would do the task and others would observe. So the first lesson I'm going to talk about started off being led by the teacher. Everyone had a pair of compasses, pencil and paper. How can you use these to construct a circle? And it's year 7, so many of the children will already know how to use compasses, and those that don't can copy those who do. They can teach each other. Everybody draws circles. And then at some stage, the teacher said, compasses are a tool for getting equal lengths. So that's the kind of thing that was going on. Lots of fiddling about how to use them, that sort of thing, you can imagine. And then after a while, the teacher draws a straight line segment on the board and says, how can we draw a path that has a constant distance from this? And the students give various ideas. And then it moves on to how do we deal with the ends of the segment? So the sort of thing that was going on was this to start with. And you can see that a couple of the points are a bit further away from the line segment. I think one of them was put there by the teacher herself to raise the issue, what do we do with the ends of the line segment? And there was discussion, and she reminded them that a pair of compasses is the tool we have to get equal distances. Big clue there, looking at this end. And gradually the whole class got to the stage where they realized, or they talked about, or they developed this idea that you would have the arc of a circle at the end, and that the pair of compasses had given you the equal distances that you wanted. So from there, the teacher went on to ask the students to try to construct the perpendicular bisector of line segments. And angle bisectors, we would call them angle bisectors, but actually they were asked to draw a line which was the same distance from, all the points on it were the same distance from 2 intersecting lines. What can we use to get equal lengths? What do compasses do for us? Why would I use the compasses? And the teacher used the word same distance, equidistant, symmetrical, frequently throughout this part of the lesson. And some students drew their ideas on the board, and the teacher placed some wrong points and asked, how do we know that these are wrong? This took quite a long time, but we've got a 70-minute lesson. There's a lot going on. And then physical activity was used at the end of the lesson. They all went down into an open area and had to stand in places that were the same length from a given point, or the same distance from 2 points. Here's the 2 points. I think they're Pringles canisters. These pictures were not from the school where I did this work. These pictures are from Jim Noble, the international school in Toulouse, which he let me use. So there's the 2 points. Where can you stand so that you're equidistant from those 2 points? And here's some more students. You can see one of the points is over on the far left, and the other one is off the shot on the right here. And they're making a perpendicular bisector of a line segment. So the second lesson was the students having paper and pencils, and there were also diagrams drawn on a whiteboard, and students were asked to suggest points that obey a rule. The language for this lesson is about obeying a rule. So where are the points that are a certain distance from another point? and that's partly done on the whiteboard. And where are the points that are at the same distance from 2 points, and where are the points that are the same distance from 2 intersecting lines? This was all about points obeying a rule. And students repeated the constructions by, at this stage, drawing rough diagrams of suitable points. So we haven't got pairs of compasses yet, but they're drawing rough diagrams of points that obey a rule. And then the pairs of compasses are given out as a way of joining up the points for the circle and locating particular points. The emphasis is how to use the pair of compasses to make points. And some of the points are joined up using straight edge. The word locus was introduced to describe where are the points that obey the rule. So, for instance, you've got 2 intersecting lines. Where are the points that obey the rule that they're the same distance from the intersecting lines? And then we'll join them up. That gives us the angle bisector. And at this stage, we only know this from symmetry. During the second part of the lesson, students took part in the physical representation, just like the other ones did, but the language this time was about finding points which obey a rule, and the word locus was used. And one student called out, "This is what we've just done." And this was followed by discussion about why the use of equal lengths had enabled them to make certain lines. Why the drawing method that they'd used had worked. But the drawing method was about points and joining them up. Lesson 3 started with a physical activity so they were asked various things. Stand the distance of this rope from this spot. So they all used the same piece of rope to decide where to stand, and stand somewhere so you're the same distance from these 2 trees. And where would you steer a boat? Spelling mistake. So that it's always the same distance from these 2 banks of a river. And the banks of a river were straight lines. And after that physical activity, the students returned to the classroom and were asked to construct on paper the same shapes and pathways as they'd acted out physically. And they were asked to work them out using their memories. And the teacher worked with a small group of students, asking them what they remembered and how they could reproduce it. And she said you could use the pairs of compasses when equal lengths were needed, sometimes showing them how to do it with arcs and then asking them to do it again for themselves. So this group were beginning to use the compasses to think about how intersecting arcs could help you draw the lines. And 15 minutes of this lesson were given at the end for the learners to develop statements that link the physical activity to the pencil and paper constructions. And by that point, some of them have been shown by the teacher how to do the classical constructions. So 3 lessons that came from the same initial agreed plan, but became rather different because of the order in which things happened and the ways that teachers talked about things and the introduction of the pairs of compasses and how the compasses were used. The similarities were the teachers' stated intentions. The forms of their interactions were similar. There was asking, prompting, telling, and showing. They referred students to other students' work. They all of them had to work out how to do the constructions, but that involved quite a bit of showing from the teacher about how to use intersecting arcs. And students had to explain their choices and actions, and all the teachers praised the accuracy in drawing when they were using compasses and straight edges. And the students' written work was similar. There were rough sketches and neat constructions in all 3 lessons. The differences that I think led to different conceptualizations were in the order of the tasks, the different subtasks, different things said at different points in the activity, what was said to the whole group or small groups or individuals, different order of the loci, different phrases emphasized, different tools used at different times. And the compasses were used differently, I felt, from the lessons. In some lessons, their use was emphasized to reproduce equal lengths. But as far as they were used in a general understanding of loci, they were used to fill gaps between points by drawing arcs. Lines were used to join points. There were sets of points which had certain properties, sets of points that obeyed a rule. It's not quite the same thing. There were trajectories. These are moving points that come from relationships between equal lengths. You may have seen that in the girls who'd made the perpendicular bisector, obviously seemed to be walking along it. Or loci were reproductive constructions of physical situations, beginning to get towards them being used as geometric tools for solving problems, such as equidistances from a line segment. And the issue for me is, when broken down into separate actions, there weren't many significant differences in the lessons, but each lesson was distinctive because of order and language, the ways that things were introduced and the ways that they were used. So teaching can't be just described as a collection of actions, utterances, tasks, examples, groupings, and what is the topic that we're learning. So those discrete actions fit together to make a continuous experience in which the teacher is guided by her personal perception of a general relationship. Different language, different sequencing, different emphases, different comparisons, different connections can be made by different teachers, acting out their own continuous sense of working with loci. These are not necessarily right and wrong, they're just different. And that continuous being that comes from the teacher's understanding gives a coherence in the relationships among tasks, language, emphases, prompts, and other components. Continuous threads of mathematical awareness. Those threads were different in the 3 lessons. And not all of those threads would lead to understanding this as a construction for bisecting an angle. And certainly not all of those lengths would lead to thinking about 2 line segments, not 2 continuous lines that I can extend as far as I like in either direction, but 2 line segments. I've put 3 dots that are on the angle bisector, but one of them, 2 of them, is quite hard to say. How are those points the same distance from both line segments? It's really only the one tucked away in the middle where same distance from each line segment makes sense for an angle bisector point.